All right, so here is an example on how to do angular acceleration. This is on slide 19. So basically, you want to think of the equations exactly like the linear equations, okay? So we have xf equals vt plus x naught, okay? And then the angular version, we have theta f equals omega t plus omega naught, okay? Vf equals at plus v naught. So we have omega f equals alpha t plus alpha naught, okay, where alpha, remember, is the angular acceleration, omega is the angular velocity, okay? And so then the other equations, we have delta x equals 1/2 at squared plus v naught t. So we have delta theta equals 1/2 alpha t squared plus omega naught t. Okay, see how it's exactly the same, right? It's just, you're just changing the variables, okay? And then we also have vf squared equals v naught squared plus 2a delta x. So that would be omega f squared equals omega naught squared plus 2 alpha delta theta, okay? So the easiest thing to think about is just literally try to think about it as if it were linear and then change everything to angular, okay? All right, so the example problem has a propeller of an aircraft spinning at 10 revolutions per second. So that's kind of a velocity, okay, or angular velocity, when the pilot shuts off the engine. So that's probably going to be the omega naught. The propeller reduces its angular velocity at a constant 2.0 radians per second squared. Okay, so you should recognize these units as being a unit of acceleration. So that's your alpha, okay, your change in angular velocity over time, for a time period of 40 seconds. Okay, what is the rotation rate of the propeller after 40 seconds? Okay, so that's going to be the omega final. Okay, and then it says, is this a reasonable situation? I have no idea why it says that. Let's see. All right, so basically just like in the other ones, you're trying to look at what variables you have and then picking out the equation where you have all the right stuff. Okay, and that's literally all you're going to do, just like you did with the regular kinematics equations, okay? Now, the only trick here is you need to look at these units, okay? Revolutions per second is not all right, okay? Because radians is like meters, right? Radians is kind of the common unit. So I'll have 10 revs per second, okay? And then remember, once around the circle, 1 revolution is 2 pi radians, okay? And then usually we don't leave these answers in pi. Sometimes you'll see them in pi, but not so much. 2 times 10 times 4. Okay, so this is going to be 62.8 radians per second, and that's what we're going to need to use. All right. Luckily, this is already isolated, so all I have to do is plug in what I know, 40 seconds plus 62.8 radians per second, okay? Now, you have to be careful with the signs, right? Because if it's rotating at a certain, direction, let's say this way I'm going to make positive, okay? It's telling me that it's slowing down. It's reducing its angular velocity. So we're going to know if this is a positive, this is going to have to be a negative, okay? Because it's going to be slowing down. So that's actually going to be a negative, okay? So 2 times 40 is negative 80. Kind of looks ugly. Try that again. Negative 80 radians per second squared plus 62.8, not squared, seconds, right? Because one of those is going to cancel, radians per second, okay? And how I know that, right? Because look, you have to add those together. Apples have to add to apples, right? Apples and oranges can't add up, okay? And then that's going to be final velocity of negative, 17.2 radians per second. Okay. All right. Now it says, is this a reasonable answer? Well, probably not, right? Because if it's going to be slowing down, it should slow down and then end at a stop, right? So if this starts with a positive velocity to start with, right, that would mean that the propeller is spinning, say, counterclockwise. And then after the 40 seconds, it's now spinning the other way. Oops, that's not the other way. It's now spinning the other way or clockwise because of this negative. Okay, so that doesn't really make sense. I mean, in theory, I guess if you continued to push it, it could go the other way, but I don't think propellers probably work that way, right? They probably just kind of spin one direction, I would think. So I would say, no, this is not reasonable. right? Because I feel like this should max out at 0, right? Like 0 and then it stops and then it's over, right? So I would say this is not a reasonable situation. Okay, and that's the example.